Good morning, everyone. In today's video lecture, we will learn how to design and optimize an immediate release dosage formulation using Design Expert software. Now, we can see here if we open Design Expert version 13 software, we'll see this screen. So within this design, we can see here a lot of designs. Okay. First of all design can be categorized into factorial design, response surface design, mixture, and custom design. So if you look into the factorial design, we'll have these designs like randomized, regular to, mixed run, then minimum run, multi-level, categorical, miscellaneous, split, plot. Okay, then we can also see a response surface design like central composite, box bank, and definitive screen. Then you can also see split plot design. You can also have mixture design. Okay, moreover you can do some custom design also. Okay, so actually which design you will follow, it is actually depending on your literature review and your type of formulation. For example, uh, in most of the cases, for nano formulation or some other formulation, we sometimes use you'll see in literature that box bank and design. Then in some of the cases we use central composite design. Okay, moreover in some cases, for example in today's immediate release dosage formulation design, we'll use optimal design. Okay, so I have separate video on each of the design. Actually whatever your design is, your whatever your design it is, actually the statistical analysis and the optimization is much more similar for each of the cases or each of the design. Okay, now we'll see how we can optimize and develop and design a formulation using this design expert software. So upon the review of literature, we have found out that our design, if it is optimal, uh, then it could have a better release profile. So for this, we'll click on the optimal. Then in our uh, design, we have kept the concentration of two excipients as the uh, factor, as the independent variable. Okay, so these factors actually are the independent variables. So we have a lot of things to be kept as a factor. Our drying rate could be a factor, our mixing rate could be a factor, our coating rate could be a factor, our spray pattern could be a factor, our percent of excipient could be a factor, our binder could be a factor, disintegrant could be a factor. A lot of things could be your factor. Okay, actually depending on uh, your choice of the design and your consideration of the factors. Okay, so first of all, in this design, let's keep the factors. Actually upon the review of literature, we have found out that in our formulation we have used a lot of excipients like calcium phosphate, lactose monohydrate, gelatin starch, sodium starch glycolate, magnesium stearate, talc, along with the API. So within these excipients, we have kept two factors as uh, the independent variable, as it has a greater effect on dissolution profile, which is the uh, response. Okay, so I'm just putting this. So for our uh, design, we have kept three levels: low, mid, and high, for their optimization. So upon the trial and error, we have set the concentration or the percentage of the sodium estrus glycolate from 4 to 6, 4 to 8, and the pre-gelatinous starch percentage from 6 to 12. Then next, here we can see a lot of statistical parameters. You uh, just decrease the lack of feed point to 0. Okay, because if you keep this high, your total run will be increased, which will increase your cost and time. So we have kept this as minimal as possible. So our total run should be 9. Then click on the next. So it's time for choosing our dependent variables. So in our design, we have kept three we have kept 5 factors as the dependent variables, like disintegration time, friability, hardness, and percent drug release. Okay, now I will put the factors one by one. So I have put all of the variables. So these are our dependent variables. Now we'll click on the next. So we have nothing to do here, just click on finish. So we have prepared our design. You can see this is factor 1 and factor 2 are sodium esters glycolate and pre-gelatinous starch. These are our uh, independent variables. We have a total of 9 runs. This has been given by the design expert software. Now it's our task to prepare the formulation, prepare the granules by utilizing this formulation. In fast formulation, we'll have sodium esters glycolase of 4%, and this is as 6%. In the second formulation, we'll have this as 8%, and it starts as 6%, and so on. And by utilizing this, you will prepare the 9 granules, and these all formulation should be compressed into tablet. And after that, we will have some tablets, and it's then we'll check the friability of those. Each of these batch tablets will check the disintegration time of those tablet, will check the hardness, will check the drug release at 15 minute and drug release at 30 minute. Okay, so uh, now I have already uh, done this result. I have already done this test. Now I will put the value here one by one. So let's start. So I have already put the data. Actually this data has been found after undergoing the test. We have prepared the granules. After that we have compressed it into tablet, and the disintegration time, friability, dissolution, hardness, all of the parameters has been checked. Okay, now it's time for analysis. So first of all, for the analysis we need to click on disintegration time. Now click on start analysis. Now it's time for clicking on the parameters, so A and B. Okay, I have clicked on this. After that we'll click on ANOVA. So here a lot of statistical parameters, as you can see. So your model, okay, it is a factorial model. So sum of square, degree of freedom, mean square, these are some statistical tool. So you need to focus on the f value and p value. Your p value is, if it is point less than 0.05, then it is significant. Obviously all of the value is 0.05, less than 0.05, so it is significant. Then f value, it should be higher than uh, the more f value, the more your result would be significant. So it is 71.2, that means your result would be significant. Okay, the model is significant. Then fit statistics, it shows the standard deviation, it shows the mean, coefficient of variation, then R square value, adjusted R square, predicted R square, and the adequate precision. So you can see your adjusted R square value is higher than zero point 0.9, so very high value. Then adequate precision is 25. Okay, then model comparison statistics. So these are some statistical parameter. Now check the coded equation. So this equation is important for your analysis. In your publication you need to show this disintegration, your coded equation. Also here is the actual equation. Then click on the diagnostics. So here normal plot of residual, so it shows how your data is aligned with the normal value. Okay, so the dots are your data. Okay, so it can be shown that your data is much more aligned with the normal value. One of them is slightly deviated. However, your data is very good, your result is good. Now residual versus predicted, it shows also the how residual it is from the central line. Then residual versus line, number one, number two, three, four, five, six, seven, eight, nine. So all of the how they have deviated from the central line. This is the first run, this is the second run, this is the third run. So here all of them has gone through. Then residual versus factor, we can see here all of the data. Then box cox plot, predicted versus actual. This is important because predicted value is your calculated value, which is found from your uh, software. Okay, from analysis, from which is found from computer generated. Okay, and actual value is your lab test value. Okay, then disintegration time, the leverage, DFFITS, DF betas. Just you need to read all of them. But now you can check your report. So what is the overall report, evolution report of your result? Okay. So how they have been changed. So this is your actual value. So this value you have found from your uh, lab test. Then this is your predicted value. This predicted value is from your computer. Okay, software. Then this is a residual. Residual means just subtract this from this. You'll find this. This from this. You'll find this. Okay. Okay. Then leverage. So cook distance. So all of the value you can check. Now click on the model graph. So you can see how your result has changed. Your dependent variable has changed with the increasing or decreasing of your uh, independent variables. So Remester's glycolates, upon the increasing of this, your disintegration time has decreased. If you click the all factor, you will also see this result, negatively related, then interaction, then contour plot, then predicted versus actual. So it shows how these are aligned with each other. So this is predicted one and this is the actual one. Actual means you left value. And finally the 3D surface. This is one of the interesting figure, because it shows the overall change of your data, how they have been changed. Okay, so now let's start. From 6 to 12 it has increased. From 4 to 8 it has increased. From 4 to 8. Okay, upon the increase of the sodium esters glycolate, your disintegration time has decreased. That means your disintegration has increased. Upon the increase of your pre-gelatinous starts, your disintegration time has slowly decreased. Okay, so everything is getting decreased. Everything is decreased. Okay, so this is the overall result. That means both of your uh, both of your independent variables are negatively correlated with the disintegration time. So this is the overall data, and by this you can easily analyze your data. Now our second one is friability. So just as the same manner, click on the state analysis. First of all, you need to click on that, otherwise your result would be blank. Okay, you can see your result is blank. So why these are blank? You know, because you need to click on the effect, you need to click on each of them. Okay, just click each of them. After that, come into the ANOVA and you can see the result. Oh wow, it is significant, less than 0.05, and F value is very high. Then adequate precision is high, R square value is 0.99. Wow. Then your correlate equation, actual equation. Okay, then your diagnostics, all of them are aligned. Residual versus run, much more aligned. Residual versus factor, leverage, your report, all of them has good result. Okay, predicted versus actual, aligned with the central line. Then model graph, negatively aligned, no problem. All factors negatively aligned. Interactions, okay, so how friability is getting changed, just negatively aligned. Then contour plot, predicted versus actual. And lastly, the 3D surface. 3D surface shows that whenever you are increasing your pre-gelatinous starts 6, 9, 12, then it is getting decreased. Friability is decreased. Whenever you are increasing your sodium esters glycolate 4, 6, 8, then it is decreased. Okay, so this is the result. By the same manner, you can also check your hardness. Click on there. I'm just showing this. So it has again been analyzed. Just check on this. Check on the ANOVA. It is significant. Okay, that means your result is significant. Your result is good. Your R square is 0.99. That is good. Adequate precision is more than 4. You can see this is more than 480. Okay. Diagnostics, model graph. Okay. 3D surface. Wow. The curve is also good. Predicted versus actual. They are much more aligned. Contour. Okay. Then drug release at 15 minutes. Start analysis. First of all, click on there. Okay. Click on the ANOVA. Okay, model graph, 3D surface. You can see the result. Drug release is 30 minutes. Start analysis. Click on there. So now whenever you will click on ANOVA, then it would be analyzed. Just check. Whenever I will click on ANOVA, then it would be analyzed. Click and analyzed. Okay, so it is also significant, although it is somehow higher value, but it is less than 0.05. Okay, diagnostic, model graph, 3D surface. So you can see your release pattern is nearly 100%. Wow. Anyway, after doing all of the analysis, now it's time for optimization, because this is the quality by design approach. Utilizing the quality by design approach, now it's time for analyzing your data. Okay, because by utilizing quality by design, which is under the ICH guideline of Q8, Q9 and Q10, quality by design works with some predefined specifications. So what are our predefined specifications? Predefined specifications are our dependent and independent variables. So we work with these predefined specifications, and actually quality is built into there. The quality of our ultimate tablet or immediate release formulation is built into this statistics, or built into this um, design. Okay, into this formulation. Okay, we have built the quality. Now it's time for optimization, because within by utilizing these statistical parameters and by utilizing this data, you will find out a uh, response or optimization. So first of all, you need to click on the optimization, click on the numerical. Okay, so sodium esters glycolate, you can see all of your dependent and independent variables. Okay, sodium esters glycolate, it should be in range, no problem. Then pre-gelatinous starts, it should be in range. Then disintegration time, so let's see, say what should be our disintegration time, it should be more or high. We always know that as it is our immediate release doses from, obviously its disintegration time should be decreased, its disintegration should be increased. And if disintegration is increased, then its disintegration time should be minimized. Okay, if we minimize our disintegration time, obviously then we will have our uh, fast disintegration, so it is minimized. Then friability, so let's say whether we want friability more or high. Obviously we want less friability, because friability is the attendance of the tablet breakage. Okay, so it should be minimized. Then hardness, actually there is nothing to say about hardness, because if it is too hard, then it would be very risky, it would not ultimately get disintegrated. Okay, and if it is very low hard, if it has very low hardness, that means it would be very soft. So actually hardness should be in range, click on this in range. Okay, in which range? In the usual range that we have used. Okay, then drug release at 15 minutes, obviously you should say what should be our drug release. Obviously it should be maximized, because we want the highest dissolution, better dissolution, because it is immediately dosage form. So drug release as 30 minutes, it should be also maximized. So one question may arise that why we have checked the true release pattern time. Actually for having a robust data, we check the release pattern in 15 minutes and release pattern in 30 minutes, because the ICH guideline tells about this. Anyway, now after doing all of this, just you have to click on the solutions. So we have maximized this, we have minimized friability, we have minimized disintegration time, we have keep this in range. Okay, now it's time for solution. Just click on the solution. Whenever you click on the solution, then you can see your result. Okay, this is your result. You have a lot of solutions. Okay, within this all of the constant, you it is in range, this data is necessary for your result. Okay, I'll just copy paste on this, no problem. So upper limit, lower limit has all set. Now this design expert will optimize the formulation. So this is your formulation. If you use sodium esters glycolase in 8% and pre-gelatin starts in 12%, then you will have disintegration time of 1.17, fiability of 0.3, hardness 4.14, and release pattern is 77, and ultimate release pattern would be 99%. So this is your optimized formulation, and by utilizing the design expert software, you can easily have a very statistically relevant and statistically satisfied data. Okay, so by utilizing and by this manner, you can easily uh, undergo the optimization. So this is the overall approach for doses from formulation, and by utilizing this statistical parameters and by utilizing this design expert software, we by this way prepare a formulation. And in many of the article you will see that the approach of the design expert. Okay, so all of the graphs has been shown here, so you can also see the relation of one another. Okay, the contour plot, all factors how they are related, whether proportionally or disproportionately related. Okay, you can see all of the data at a time. Okay, and moreover you can do some point prediction if necessary. Okay, this is your overall test report has been shown here. Okay, then confirmation, if you want any confirmation, just put the value here, your disintegration time was like that, your friability was like that. Okay, just put any value. If you want any response, you can put the value here. Okay, just I'm putting any value here, 90. Okay, then you can do different statistics. Okay, by putting the value here. Okay, then coefficient table, so this is your overall table, whether your p value is less than or less than 0.05, because you need significant data. So a lot of statistical parameters here, you can learn a lot by utilizing this. So this is the overall design. Actually our main result is the uh, this is our main solution. Okay, you can see our main solution. So by utilizing the design, we have easily found out that our star's glycolate should be 8% and pre-gelatin ester should be 12%. So this is the optimized formulation, okay, which is statistically validated. Now I'll just show you how you will save the data, because it's important. Click on the right and copy. You can also export the table to Word. Just copy and paste into the Word. Okay. Now I will also show you how to download, or how to download the figure. Not download, just how I will generate this. Okay. Just click on copy and use the custom data and click on OK. So it has been copied. If you go to the software, or if you go to the Microsoft Word, you can easily paste there. Just click, right click. You can also export this. Okay, I will suggest you to copy this. Okay, or click on the export as bitmap. Okay, if you export as bitmap, then you can easily copy and paste this. Okay, so this is the overall approach for uh, preparing any dosage form utilizing the design expert software. If still you have any confusion, please inform me in the comment section. And here you can read a lot about the parameter. Okay, whether it is good or bad, whatever the it is. Okay, you can also see your summary here. There are a lot of things you can learn. Okay, just go through this. Okay, but the main thing is the analysis. You should understand this. So this is the overall video from uh, using design expert software for the formulation of immediate release dosage form. If you have still in confusion, please inform me in the comment section. Thank you.